A very good morning, students. Welcome back to Programming for Problem Solving course. In the last session, we have concluded many things, like we discussed the complex structures concept, that is array of structures, and we said it is an important LAQ for your external exams. And we have also seen the programming related to that complex structures, that array of structures. Then we have also seen one of the important concept in your fourth unit, that is union. So mostly in union they will try to frame the SAQs. So they ask the difference between structure and union. Okay. So that SAQ, short answer question, you can find in my notes, in my provided notes. So that union concept also we have concluded. Then we have also seen the recursion, the concepts related to recursion. And we said recursion is one of the approach to achieve the repetition in programming, in C programming. So we said many modern computing programming languages, they do support recursion. And one of the programming language which does not support recursion is COBOL, we said. So the recursion is nothing but if inside your computer or inside your computer program, if a process or if a function, if it calls itself, we are saying this process as a recursion. Or if we define this recursion more specifically, a recursion is a process in which a function calls itself. If you read this second point or second statement in this particular slide, you will understand that one. So we said recursion is a process in which a function calls itself. Okay. Generally we are making a function to call itself so as to achieve the recursion. Okay. And many programmers they use this recursion as a repetitive approach. Okay, as a repetitive algorithm or repetitive approach, in the sense something to it is a technique in which we achieve the looping process, isn't it? So there are two different ways in which we can achieve this repetition in programming. That is, the first approach is using loops and the second approach is using recursion. Okay. Then we said we have some examples in order to understand the concept of recursion, that is finding the factorial of a given number, and finding the Fibonacci series up to the given number, and finding the GCD of given two numbers or more than two numbers. Okay. So in this way, I mean, by studying these three algorithms, and these three algorithms, they are important both for your external exams, external labs also. Okay, if you prepare for these three programs, you can attempt at least one question in your lab. Okay, so they are equally important for your external exam as well as external lab, external theory exam as well as external lab practical. Okay, so generally whatever examples we are studying over here, that is finding the factorial, printing the Fibonacci series, and finding the greatest common divisor, that is nothing but GCD or HCF. These three techniques, I mean, we do these three examples we study in both using loops or using recursion. Okay. Using loops we call the technique as iterative approach. Okay, iterative definition or iterative approach, and using recursion is nothing but the recursive approach. Okay, so we need to study these two approaches for every example whatever we are going to study. Okay, so without wasting much of the time, I will give one simple example where I will explain in detail more about this recursion concept. So whenever there is a loop, we need to have a termination point, isn't it? For the loop, we need to have a termination point. Otherwise, what will happen? The loop will enter into infinite. Simply, it will keep on repeat itself, and it will keep on execute the statements whatever you are keeping inside that loop. Okay, so I will show you with the help of loops how a loop will enter into infinity. Then with the help of recursion, how recursive technique enters into infinite repetition. Both we will see, and how we terminate the loop as well as the recursion, that also we will see. First I will explain with the help of a simple example, then we will go and study these three things. Okay, then we'll, if time permits, we will also start the fifth unit, that is pointers concept. Okay, pointers concept I'm planning in 2 classes, and then files hardly it will take, I mean, in three to four classes I will try to complete the uh, what we call the fifth unit. That is, we have to discuss two things over there. The first thing is the pointers, and the second thing is files. Okay, so just go to the programming part. Yeah, here I'm opening my dev cpp, and in that I'm taking a new file, source file, and here I will write my program. That is, yeah, we need to discuss the first we need to discuss the loops, using loops, how we are achieving uh, iterations, that we need to discuss. Hash include stdio.h. Okay, then int main of void, take the curly brackets, opening curly bracket and closing curly bracket, and in it you take a simple loop to print a message, or to print a counter on the output screen. So how we do generally that one, we need to do the initialization. So I'm doing initialization out of the loop, then I'm taking the while. Okay, so here what I'm doing, I'm simply keeping I. Okay, I'm not doing any condition over here, I'm simply keeping I, and then in it I'm printing I. Okay, printf of percentile d comma I value you print, and then you do I plus plus. Okay, so now what you will see on the output screen, yeah, just go and check here, sample.c and overwrite. Yes, so here take the \n, because we need the output in a new line. So just compile this program. Okay, program got compiled. See, simple statement I kept over here, nothing, no condition. So if you don't put the condition, what happens to the loop that we are testing now? So then run. Okay, it is not printing anything, so it is not entering basically. So simply put true, always true, then compile, run. See, it is entering into infinite, it is keep on printing the value of I, it is keep on incrementing, and it is keep on printing on the output screen the counter. It is started from what we call 1, and it is keep on incrementing. Okay, as you can see over here. Just close this one. It is I mean, why it is happening, why it is keep on printing the value of I on the output screen, in the sense it is repeating itself. The control is I mean, iterating here itself. The control is like a loop. Okay, now the control is inside a loop, and which is never ending, because we didn't put any condition over here. So how we can stop? So I mean, in order to stop, you need to decide how many times you want this loop to iterate, how many times you want this loop to repeat itself. Let us say if I want to make this loop to repeat itself for 10 times. So what I have to do, I must be always less than 10. So now what will happen, it will print the value of I from 0 to 9, because once the I value becomes 10, this condition fails, isn't it? This condition fails, and the loop will exit. Save this. Now you try, it will print only the first 10 numbers, 0 to 9. Okay, run. See here, we got 0 to 9, and it is terminating itself. The loop is breaking after printing the 9. When I value goes to 10, then what will happen? This condition fails, because 10 is less than 10, we are saying. In every iteration, I value increments 1 by 1. So in the first iteration, I value prints 0, second 1, 3, 2, 3, 4, likewise up to 9. And once the I value becomes 10, this loop will terminate. So this is one approach to achieve the repetition in programming. So without the condition, because the condition plays a vital role over here in order to terminate the loop. The condition plays a vital role in order to terminate the condition. Here that statement I will write. Condition plays a role in terminating the loop. Okay, condition play role in the condition plays a role in terminating the loop. So without condition, what happened? The loop entered into infinity. The loop repeated itself infinite number of times. It is never ending. We have seen already. But when you are, as you are keeping the proper condition, it is terminating the condition, terminating the loop. That's why we sometimes call this condition as the termination condition. Okay, termination condition for this loop. Okay, so this is the first approach in which we are achieving the repetition. So the second approach in which we can also achieve the repetition is recursion, we said. So what is recursion? If a function calls itself. So I'm taking a function with name void recfun. Okay, recursive function of integer. So I'm taking a function name recursive function. Okay, recfun in the sense recursive function, and I'm passing an integer value as an input to it. So now here remove this because we're not taking the loop now. Okay, we're not taking the loop now, so remove this entire thing. So now what I have to do, call that recursive function of, pass that I to it, pass that I to it. Okay, so next thing, we need to give the definition for that recursive function, recfun. Okay, recfun. So next thing, put again inside the function, what we have to do, call that same function. That is nothing but recursion, isn't it? From the function, if you call that same function, we call it as recursion. So inside recursion, recursive function, I'm calling that same function, recursive function, and by passing I only. Okay, and then what I'm doing, I'm printing the I value also. Printf, okay, printf %d /n comma I. I'm printing the I value. At the end, put the semicolon. And here, when you are calling the function from the same function, just increment the value of I by 1, or else you can put I plus plus also here. Okay, just we are incrementing, every time we are incrementing the value of I by 1. So initially what will happen, the control will start from here by executing the main function. Then the control will come over here, it will initiate the I value becomes 0. Then what we are doing, we are calling the recursive function. Okay, we are calling the function by passing I value. So recursive function of 0 will be invoked. Then the function will jump from here, the control will jump from here to here. Then we have, it will print the value of I, that is 0, you will get on the output screen. Then once again what we are doing over here, once again we are calling the recursive function by incrementing the I value 1. So recursive of 1 will be invoked. Okay, so the control will jump from here to here once again, here to here only, because the recursive function is this one only. So the control will jump from here to here and it will execute the statement, this printf statement once again. But this time I value will be 1 because we incremented the I value. So this time I value will be 1. So that 1 will be, that 1 you will see on the output screen. Okay, after printing the I value 1, once again the control will come and invokes the recursive function. This time recursive function of 2. Same thing, the control will jump from here to here. Here you need to receive int I. Okay, once again the control will jump from here to here and it will print the I value, same thing. And this process is a never-ending process because there is no terminating point for this loop, for this recursive call. So what will happen, the control will enter into infinity and it will keep on print the I value. Just compile this program to see for errors, no errors, then execute the program to see the output. See, as you, yeah, it is printing I value as 0 only. So here you better take I plus 1. Okay, now you see, run. See, it is keep on printing I value by incrementing 1. Isn't it? Why it is repeating itself infinite number of times means because there is no endpoint we have specified for the recursion process. Okay, So in order to break a loop, what we said, the condition plays a vital role. So in that same way, in order to break the recursion, the base case plays a vital role. We say base case uh, in terminating not the loop but the terminating the recursion. How we break the recursion in the sense, how we terminate the recursion in the sense, with the help of base case. Okay, with the help of base case. In a loop, the termination condition plays a vital role in terminating the loop. But whereas in recursion, the base case plays a vital role in terminating the recursion. So what is the base case? Base case in the sense, when I value reaches to some point, so that we need to put. Okay, when I value reaches to some point, that is if I value, let us say if you want to repeat this loop for 10 number of times, if I value is less than uh, 10, if I value is less than 10, no, if I value equals to 10, we will say, if I value equals to 10, then what we are doing, return 1, that's it. If I value equals to 10, return 0, we can say. So this is the base case. This is the base case. So here the program will be terminated. So now what will happen? Compile it. Okay, it is saying something. Okay, okay, because this function is not returning anything. So make it as a return function int. Here also make it as a return function int. Now you save, compile, yes, run. As you can see, it is printing only the first 9, 0 to 9. Okay, 0 to 9 it is printing and it is terminating. So this is how, what is the base case? When I value is reaching 10, that is the base case. Every time the I value is incrementing by 1, and when the I value is reaching 10, we are stopping the function. Okay, so this is the base case, and the base case plays a vital role in terminating the recursive process, recursion process. Okay, now go to your PPT and see the next thing. So finding the factorial. So we have seen two things: how the loops, repetition process through loops will enter into infinity, and what we have to do in order to stop that infinite repetition process. Simply we need to make the proper termination condition so that loop will be terminated. Then with recursion, we said recursion also a way to achieve the repetition, and if you don't put the proper base case, then the recursion will enter into repetition through recursion will enter into infinite repetition. So to avoid that one, what we have to do, simply make a proper base case into your application so that the repetition you through recursion gets terminated. Okay, these things we have discussed. Now the uh, finding the factorial of a given number, the two approaches, through recursion and through iterations, iterative approach and recursive approach we need to see. The first one is the iterative approach, iterative definition. The factorial of a number is nothing but the product of all the integral values from 1 to that number. This we already know. So if you are finding the factorial of 6, then what you will do, from 1 to 6, whatever numbers we have in between, simply get the product of all those numbers. So then you will get the factorial of 6. So the iterative definition, what it will say, factorial of n, it is if n value is 0, the factorial of 1 factorial of n is 1. Okay, if n value is 0, for we know this, isn't it? Factorial of 0 is 1. So if we are here, what we are saying, we are calculating, we are finding the factorial of n. So this value, factorial of n, it will be 1 if n value is 0. Okay, if other than n, if other than 0, if it is greater than 0, what we have to do, we need to get the product of all the integers up to that n. Okay, that n can be any positive integer. Okay, any positive integer from 1 to n when n is positive, and if n is 0, simply factorial of n is 1. Okay, this particular thing we need to remember when we are implementing the factorial of a given number in iterative approach. So yeah, factorial of 4 is nothing but 4 multiplied with 3 multiplied with 2 multiplied with 1, and that is 24. Okay. Yeah, the recursive definition here also the same thing. Inside recursion we are not getting the product from 1 to n. So rather what we are doing, we are simply writing factorial of n as n multiplied with factorial of n minus 1. Okay, n multiplied with factorial of n minus 1. So this factorial of n minus 1, what it will become? This will become n minus 1 multiplied with factorial of n minus 2. Factorial of n minus 2. Likewise, we will keep on right until and unless we get the base case. The base case is nothing but factorial of 0. If factorial of 0 is reaching, because in every iteration what you are doing, you are decrementing the n value by 1. As you can see here, we are saying initially we are saying n multiplied with factorial of n minus 1 we are saying. Then n minus 1 multiplied with factorial of n minus 2. Then n minus 2 multiplied with factorial of n minus 3. Likewise, we get at the end what we will get? We will get factorial of 0, isn't it? That factorial of 0 is nothing but our base case. So in short, we have to do this repeatedly as long as you are not reaching the base case. So once you reach the base case, you can stop the recursive definition. So a function is defined recursively whenever the function itself appears within the function definition itself. The recursive definition of a factorial can be shown as follows. So like this: factorial of n, if the n value is 0, we are saying factorial of 0 is 1. Okay, then we are finding the factorial of if n value is not 0, if n value is other than 0, then n multiplied with factorial of n minus 1, then n minus 1 multiplied with factorial of n minus 2. Likewise, we do the calculation until and unless we reaches what? We reaches the base case. That base case is nothing but factorial of 0. So if you reach the factorial of 0, you can stop recursive process over there. Okay.